So previously we stopped at this portion over here, stating that this is the force out of balance. Okay, because it's out of balance, in fact, because it's moving out of balance. Now, because there is two of this, okay, because there is, oh yeah, one more thing is that because we're trying to find the forcing function, okay, because eventually you want to find the forcing function so that you will know what are the parameters to actually typically you want to know the forcing function. That's all I want to say. There's a little few setup that I not much understand, but nonetheless, let's do it first. Um, so um, so the forcing function itself is so in our case the forcing function, which is the force out of balance, multiplied by cosine omega t due to the turning of the shaft itself. Okay, so therefore we have this value. So how do we have this, right? So in fact, this portion here, okay, this portion here is this portion. While cosine omega t, omega is actually our frequency, right? We just found it earlier. Okay, so you're just substituting the stuffs. And since we have two eccentric mass, because we are talking, so because our system has two masses, okay, there's two of this. So therefore we just multiply by 2. So the result will be this value over here. So now comes a very unintuitional understanding. Until now I still don't know what the fuck is that. So there is a hidden meaning in there. It says that, okay, let's take a look. It says that at the speed of 900 revolution per minute, a stroboscope, okay, so what is a stroboscope? So this is a stroboscope. It tries to measure the amount of the rotation itself. Okay, so this is just the stroboscope. So showed the eccentric weights to be at the top at the instant the structure was moving upward. So the eccentric weight is at the top. So where is the top? Is this the eccentric weight, the black color one, or is this holding the eccentric weight? I have no idea. And then moving upward. So it says that in fact this whole mass is moving upward. So when it's moving upwards, the the weight itself is at the top. So there's no meaning, right? I can't think of any meaning to squeeze out to explain this. But nonetheless, he has a meaning, okay? So there is only one instance, okay, one explanation is that instead of this piece, okay, instead of it being on top of the structure, okay, it is over here. Okay, what I mean, it is like that, okay? So when it start to move up, okay, this whole thing start to goes up over here. I have no idea, okay? I think this is so, okay? But nonetheless, the graph itself plays a part. Okay, the question itself plays a part. So it talks about show the eccentric weight, meaning that you are talking about the small m. Okay, you're talking about the small m. So hold on again. So apparently you're talking about the small m, which is this m, right? So this two of them is talking about the small m's. So it's 2m, right? Because there's two masses. To be at the top isn't where the structure was moving upward. The structure itself states that it is m minus, sorry, it is m minus m. Okay. So what I would think that maybe perhaps it is indeed that they actually move from this position to this position. Then it is totally different for our shaft systems. I don't know. So there's a lot of contradicting understandings in there. So I'll make known. So you should go and make known, okay? And then yeah, so this is the only key concept. So when it moves up, okay, then things could go different. And then from this graph, okay, by x and in terms of omega n t, I don't know why they put it like that. And then it says that the unbalanced mass, okay, the unbalanced mass means that the imbalance of this stuffs, these masses are moving faster than the structure itself. Okay, so she does draw the graph. Okay, my lecturer does draw the graph and been showing this, and then for the structure itself, m minus n, which is without the balance mass itself. So it's going in this graph itself. So as you can see, this point and this point, the starting point, it's already for unbalanced mass, it already start to oscillate, while the structure itself, it is still going up, still have a phase going up. You see, so it's lagging behind by pi over 2. You see, so as you can see, when it is at top, okay, when the unbalanced mass is at 0, the structure itself is negative position. And then when it reaches this point over here, the unbalanced mass, it reaches the static position over here. So it's a little, unintuitive to say. And then, yeah, to head back to this question, you say that the structure was moving upward through its static equilibrium position. Okay, so if you were to look at the graph, static position is actually here. So this is the structure of the static. This is the static position of the structure, while the unbalanced mass itself is already up here. So in some meanings, it is saying that the signal was moving upwards. Yeah, it's still something I don't know. But nonetheless, I did point out that this is the point where it's a static position. When it's at a static position where it is before it goes up, okay, the unbalanced mass is really up there. So up where, up where? This diagram didn't specify. I don't know why they want to create this confusion. I don't know. I have no idea. But nonetheless, with this, you can know that they are pi over 2 distance apart. I mean, phase apart. So if you were to remember, from our thing, we say that if they are 90 degrees apart, okay, if the phase angle 90 degrees difference, you are talking about frequency ratio as 1, okay, which is beta equals to 1, right? So phase angle 90 degrees is actually pi over 2, right? So the difference is actually pi over 2 in this case, right? So with this understanding, then you can actually do certain stuff with it, right? You still remember last week we talked about the trial function x cosine omega t minus theta, where we say that minus theta means that there is something lagging behind. Okay, maybe the force function. Okay, this one is this, how do I say it? The structure itself is moving slower than the force function. Okay, the forcing function has a certain speed, right? But however, if you have the forcing function trying to pull a certain mass, you actually lose some of its speed. So the comparison between the forcing function with the mass with the with the mass being moved is you know has a phase angle, right? So one said that we have a forcing function pulling this down, right? F naught cosine omega t, and then pulling this down and pulling this up, pulling this down and pulling this up. So it's just going like that, right? So you have a certain force, but however you have to also overcome the mass itself and whatever things over here, right? So therefore, the outcome will be the movement of the mass itself is actually um, cosine omega plus theta or minus theta, right? It's because it is the mass itself moving, the speed itself of the speed that it is moving is much lower than the forcing frequency, right? It makes sense, right? Because I think you get what I mean. So when you try to pull a certain mass, the mass itself has a certain retardation to prevent certain forces that is pulling it, right? So there will be a certain, amount of losses due to it. So in other words, if the mass is lighter, the phase angle will be smaller, right? Because you have more forces to pull this mass. I think you get what I mean. I don't know. So this is just the concept. So let's get back. So since we know that the theta angle Okay, it's pi over 2. I've just explained why we have a theta angle. So we can say that the beta is given. Okay, the frequency ratio is equals to the frequency of the system divided by natural frequency of the whole structure, including the mass itself. Okay, including all masses, is equals to 1, right? So it will be a resonance. So in this case, they will resonate in a so it all depends whether your damping factor is it high or low or whatever. So it's the thing. So with this said, we have found we have solved for all the given parameters. Okay, we have solved for all given parameters, which is we haven't started any questions yet. So this is a very key concept of the whole system. So with this then we can start to do our question. So I'll see you in the next video to start doing the question.